Hi there, everybody. This is the last section in Chapter 11. It's about quadratic and rational inequalities. This is the only section I'll be covering today. There's a couple different ways to solve these quadratic inequalities. This is quadratic because it's got an x squared in it. This one's rational because it's got a fraction in it. There's two different ways to solve these. One is with the graph. We'll talk about that one first. So this graph right here, this parabola is the graph of y equals x squared minus 2x minus 8. And this is y equals 0. That's the x-axis. Again, this is y equals x squared minus 2x minus 8. And we want to know where x squared minus 2x minus 8 is greater than 0. In other words, where the graph of this parabola is above the graph of the line. Well, it's above the line, or it's above the x-axis. It's above y equals 0 over here. It's below here, and it's above here. That means it's above, or it's greater than 0 out here to the left of negative 2 and to the right of 4. So our solution, you can write it a couple different ways. In interval notation, we'd write negative infinity to negative 2. Now I remember on the infinity, it's always parentheses, never a bracket. I put a parentheses on the negative 2 because it's not equal here, and at negative 2 it's equal to 0. So it's not going to include negative 2. We also want 4 to infinity. Again, always a parentheses on the infinity. At 4, it's equal to 0. This is not equal to, so not including 4. And then the union of those two sets. Set builder notation. I can't remember which one they want on the computer. So first set builder notation would be the set of x such that x is less than negative 2 or x is greater than 4. And either way you write that is fine in my book. Pay attention to what the computer asks for and do that. Excuse me. Let's look at this other one here. So here we've got the graph of y equals x minus 3 over x plus 4, and that's this curvy thing. And part of the graph is down here as well. And here we have the graph of y equals 2. And again, this is the graph of y equals 2. And we want to know when x minus 3 over x plus 4, when this curvy graph is less than or equal to 2. Less than or equal to 2. Well, less than or equal really means below 2. So, well, it's below 2 out here. It's above 2 up here. And it's below 2 always over here on the right. Now this graph is actually going to approach y equals 2 as we go farther and farther out to the right here. It never actually gets to 2. In fact, it never actually even gets to 1, despite the way I've drawn it here. The point is, it's this part of the graph, it's always less than 2. So where is this fraction? Where is this curved part less than or equal to or below y equals 2? Well, it's below out here, so negative infinity to negative 11. Now at the negative 11, we've got equal to 2 here, and at negative 11, it's equal to 2. So negative 11 is included, so bracket there. And we've got another part, and that's over here. Now this thing, at negative 4, this fraction is, or this rational part of this is undefined. You've got 0 on the bottom. So this graph never actually gets to negative 4. It approaches it. It gets closer and closer and closer, but never really gets there. That's called an asymptote. Not something you necessarily need to know, but for this. But to understand what this graph is doing, we got to talk about it a little bit. So it's never going to actually get to -4, but just to the right of -4, and then to infinity going out to the right. The curve is going to be less than or equal to 2. And so here's our solution to the inequality. And again, you could write it using set builder notation if you wanted to. Again, pay attention to what the computer asks for. So that's how to do it with the graph. Greater than means above, less than means below. What if we wanted to do this algebraically, without a graph? Graphing is kind of a pain. We'd like to do it without it. Well, let's take a look at a couple examples. For the quadratic ones anyway, we'd like 0 on one side. So for this one, we would take away 4 from both sides. We get this. Excuse me. And then what we really need it in factored form as well. So we're looking for numbers that multiply to make -4 and add up to 3. That's +4 and -1. So I'm going to draw a number line right here. And on my number line, I'm going to put, I need to know where this whole thing equals 0. Well, it either equals 0 here when x is 1, right? Because 1 minus 1 is 0. I'm going to put a 1 here on my number line. Or if this part is 0, and that's when x is -4. I'm going to put -4 on my number line as well. So only ones I'm putting on here are where this thing equals 0. Now, we're going to see what happens to each of these parts. X plus 4, x minus 1, and then x plus 4 times x minus 1. In each of these 3 regions, to the left of -4, between -4 and -1, and to the right of 1. Okay, so just pick a number to the left of -4. It doesn't matter what number you pick. As long as it's to the left of -4, it's okay. Let's take -10. Okay? Well, -10 plus 4 is going to be negative. And that's what we're really going to care about here. We want to know whether it's negative or positive. -10 minus 1 is also negative. Okay? So that means out here, we've got x plus 4 times x minus 1. That's why we're looking at this. We've got a negative number, because x plus 4 we said was negative, times another negative number, because we said x minus 1 was negative also. And a negative times a negative is positive. Now we do the same thing for between -4 and 1. Again, pick a number between -4 and 1. Any number will do. It doesn't matter. As long as it's in here, it's fine. 0 is easy to do math with, so let's pick 0. 0 plus 4 is positive. 0 minus 1 is negative. Now, that means we've got a positive. We said x plus 4 was positive times x minus 1 was a negative. So a positive times a negative is negative in there. Okay. Now let's look at the right of 1. So pick a number to the right of 1. It doesn't matter what it is. Let's take 100. As long as it's to the right of 1, it's going to work, and you're going to get the same thing. I'm going to pick 100. Let's see what happens. 100 plus 4 is clearly positive. 100 minus 1 is also positive. And here, so we've got a positive number times a positive number, and that is positive. Okay. Let's look and see what we did here. We want to know when x plus 4 times x minus 1 is less than 0. Well, what kinds of numbers are less than 0? Negative ones. Right? So we want to know when this is negative. Well, we just showed that it's negative in here. So in this interval is our solution. -4 is less than x is less than 1. Now, the only other thing to think about is what happens at -4 and at 1. Well, at -4, we said this thing was 0. and we got equals 0 here. So that means -4 is part of the solution. And same thing at 1. At 1, this was 0, and we've got an equals right here. So equals. And this is the set builder way of writing it. Interval notation is really easy for this one. There's our interval notation. Either way you write it's fine for me. Again, pay attention to what the computer says. Let's take a look at this one. This one, you're doing it the same way. We need it in a factored form, just like we needed this one. This one's already in a factored form. That's actually kind of nice. So we're going to start with by drawing a number line. And we want to know where each of these parts, each of these factors equals 0. Well, this factor equals 0 at 3, so we want to put a 3 on the number line. This one is 0 at 2. And this one is 0 at -1. So where each part is 0, that's the points we put on the number line. Now that means, what that means is we've got 4 different regions to check. To the left of -1, between these two, and to the right of 3. So it takes a little time, but we'll get there. X minus 3, x plus 1, x minus 2, and then at the end, we want to do x minus 3 times x plus 1 over x minus 2. Okay, so we pick a number to the left of -1. Let's say -10. Well, -10 minus 3 is negative. -10 plus 1 is negative. -10 minus 2 is negative. And I pick -10. Really, it doesn't matter. As long as to the left of -1, it's okay. It'll still work. Now we've got x minus 3 is negative, x plus 1 is negative, x minus 2 is negative. So we've got a negative times a negative divided by a negative. That means it's negative. So negative times a negative is positive, divided by a negative, negative. Okay. So let's pick a number in between -1 and 2. Let's take 1. 1 minus 3 is negative. 1 plus 1, positive. 1 minus 2, negative. So now we got a negative times a positive, negative, divided by a negative is positive. Number between 2 and 3, let's say 2.5. Doesn't matter, as long as it's in there, it'll still work. 2.5 minus 3 is negative. 2.5 plus 1 is positive. 2.5 minus 2 is positive. So we're going to have a negative times a positive, times right here, divided by a positive, that is negative. Now pick a number to the right of 3. Say 14. 14 minus 3 is positive. 14 plus 1 is positive. 14 minus 2 is positive. A positive times a positive divided by a positive is positive. Okay.
Wally O'Donnell, if you can come to the main office, please. Wally O'Donnell to the main office.
So where the heck is the answer to this? Well, we said we wanted to know where this fraction was greater than 0. Greater than 0 really just means positive. So it's positive in here, and it's positive in here. So this is between -1 and 2. So -1 comma 2. Now at -1, this thing equals 0, and we don't have an equal sign here, so parentheses here at -1. And at 2, the whole fraction is undefined. You can't have 0 on the bottom of a fraction, so it's not going to include 2 either. And then we've got this part over here. We're starting from 3 and going to the right, so 3 comma infinity, always a parentheses on infinity. And at 3, this whole thing equals 0, because this part equals 0, and it's not equal to 0 here, so that means parentheses here at 3 also. So I hope that makes sense. There are additional videos online as well as help for the for the problems in the assignment, which again is online as well. Bring your questions to my next office half hour, and I'll see if I can answer any more if this doesn't make enough sense to you. Have a good night. See you Thursday. Bye.